All right, welcome to lecture 24. So kind of a normal lecture. I'm going to divide it up into three parts. So in the first two parts, we're going to look at another equation, another law. It's called the ideal gas law. You'll be hearing all about it. So that'll be in part A and B. And then in part C, we're going to just spend just a couple of minutes talking about one last law. So one last equation, basically. Now, before we do that, let me just remind you a little bit about what you heard in lecture 23. So let's just do a brief review. So in lecture 23, we went over um, two, well, sort of three equations really, right? Boyle's law. Boyle's law. What that has to do with what happens when you change the pressure. P1 times V1 equals P2 times V2. If you're changing the pressure, what happens to the volume of a gas? All right, now, as far as all these equations go, all these laws go, there's always kind of rules about units and stuff. So for Boyle's law, just one rule that I want you to make sure you're aware of. Me and I have spent a whole lot of time talking about it. I don't know if it came up in that last lecture, honestly, is that when you use this equation, you can put in any units, but the units must match. All right. So what do I mean by that? I mean that if in the problem they gave you one pressure in atmospheres, the other pressure, the new pressure, would also have to be in atmospheres. That's fine. What you can't do is you can't have atmospheres and then the other pressure in torr and just plug in those numbers and get the right answer. That ain't gonna work. All right, so the units have to be the same. The same thing is true with like the volume, right? So if they gave you like two volumes, that would be fine. You could put them both in, assuming they're in the same unit. If they're both in milliliters, fantastic, do it. If they're both in liters, fantastic, do it. If one is in liters and the other one is in milliliters, can't do that. You need to convert them. You need to get them in the same unit, okay? All right, so let's move on to Charles's law. All right, so Charles's law was the one that had to do with, well, what happens when you change the temperature? So it was V1 over T1 equals V2 over T2. Now, what are the rules for this one? Well, for this one, the volumes must be in the same unit. Volume, I guess we'll say volume units must match. So both volumes have to be in liters or milliliters. That's fine. They just have to be in the same unit. And then, oh, temperature had to be in a special unit. Do you remember? What unit did temperature have to be in? Temperature had to be in Kelvin. Temp has to be in Kelvin. So Celsius ain't going to work, or Fahrenheit ain't going to work. You have to have it in Kelvin. All right, last equation we talked about. This one we talked about during our Zoom session. Combined gas law. Oh, that's just putting these two together, right? Should look like that. And then the rules for this one are that the pressure, the pressure units and the volume units must match. So pressure and volume units must match. And then, just like up above, the temperature has to be in Kelvin. All right. All right, with that quick review, let's move on to our big equation for this lecture. We're going to get to it right now. Okay, on to our last gas law. All right, so our last gas law that we're going to learn about, and when I say a law, basically it's an equation, is called the ideal gas law. Now, the ideal gas law, we're actually going to spend the most amount of time on it because there's lots of things you can do with the ideal gas law. All right, so like first off, well, what is it? Well, the ideal gas law, it's something like this. It looks like this. PV equals nRT. PV equals nRT. All right, so when you look at this, there's some things in there, some symbols you probably have seen before, right? So like you can probably guess P, that's going to be like the pressure of a gas. So P is the pressure. And you could probably guess what V is. V is the volume of a gas. The volume of a gas. And then when we get to the other side, there's a couple things you've never seen before, right? N. Well, N is actually something we've talked about. It is our favorite idea in chemistry. We talked about them in what would have been like chapter 5, and we talked about them in chapter 9. Oh my God, he is back again. N stands for moles. Oh, I'm back. All right, so moles is in this equation. And that's the reason why we're going to end up using this equation for all kinds of different problems. Because now that we have an equation that involves moles, we can use this equation to relate back to lots of other ideas you've talked about previously, like atoms, or I don't know, what else do we relate moles to, like stoichiometry, all that kind of stuff. All right, so N stands for moles. All right, what else is in here? R. R, what is R? R is called the universal gas constant. That's a U there, universal gas constant. And it's a number, it's always the same number. You never put down a different number. You're always going to use this number. So it's kind of like in geometry when you did pi, you always did 3.14. Well, for us, whenever you need to put in R, you're going to put in this 0.08206. 0.08206. So we'll always put that number in. All right, now finally, the last thing in that equation after R, you see T. You probably know what T is. T, I'll have to put it over here actually. T is temperature. All right. So we're going to practice using this equation in just a minute, doing all kinds of things with it. But before we get to that, let me just make sure you know that this equation is a little more picky about units. So in some previous equations, maybe you could get away with putting in milliliters for volume, or I don't know, pressure could be in like torr, or all kinds of different units. This equation, you have to put in very specific units. If you are given a number in a different unit, you're going to have to convert it before you use it. So for this equation, your pressure has to be in atmospheres. If I give you a pressure and it's not in atmospheres, you're going to have to change it to atmospheres before you plug it into this equation. Volume. Volume can't be in milliliters. It couldn't be in quarts. It couldn't be in any other unit. For this equation to work, the volume has to be in liters. Moles is moles, so you're going to put in moles. There's no like other unit there. We'll get back to R in a minute. And then the temperature, that one's kind of like what you've been hearing before. When we do gas laws, we always do temperature in Kelvin. All right. Now, R actually has units on it. The universal gas constant, that 0.08206, there are units on that number, and they're kind of a mess, to tell you the truth. They are this is just the units. All right. The units on here are liter times atmosphere over mole Kelvin. So those units will be the ones that are on R. Now you might notice there's a bunch of units there. They match up with the other units. So that's going to work out because we need like units to cancel and stuff. So because, for example, R has Kelvin in it, that's why your temperature has to be in Kelvin. R has liters in it. That's why you need to have your volume in liters. So those units will cancel out when we're doing some math. All right, so with that little introduction, let's do an example. All right, actually, we're going to do a few examples of using this equation. So our little friend, the mole, is back. Hi, mole. All right, let's do some problems. Let's do some examples. Okay, our first example using PV equals nRT. All right, let's read this question. Let's see what it's all about. So it says a sample of oxygen gas is at 1.15 atmospheres. So that sounds like a pressure, right? At 1.15 atmospheres and 14.5 degrees Celsius. If the volume of the gas is 8,560 milliliters, how many moles of oxygen are in the gas? So a sample of oxygen gas is at 1.15 atmospheres and at 14.5 Celsius. If the volume of the gas is 8,560 milliliters, how many moles of oxygen are in the gas? Well, one thing that you're going to have to get a little used to is, kind of knowing which equation to use. So before we even try anything, let me just tell you, how do I know when I look at this that this is going to be a problem where I have to use PV equals nRT? Because, I tell you how, because I see the word moles. The only equation that you know that we're going to cover that's going to involve moles is PV equals nRT. So yeah, we're going to be using PV equals nRT. All right. Now, the other hint I want to give you, besides, oh, you got to kind of make sure you know what equation that's going to help you out, is that before we just start plugging stuff in, I'm going to make a list. And as I make the list of all these things, I need to make sure I have every number I need. And I also need to make sure it's in the right unit. So let me go ahead and make that list over here. So we'll do, let's see, P, V, N, R, T. All right. So let's just double check we have all the numbers. So basically, if this question says how many moles do we have, we're solving for N. Now, what does that mean? It means you need to have every other number, right? In algebra, you can only really solve for one thing at a time. So we better have the other four numbers. And if we have the other four numbers, we should be able to solve for N. All right, so N is what I'm looking for. How many moles? All right, so let's go back to the question. Let's see what we have, and let's see if it's in the right unit while we're at it. So a sample of oxygen gas is at 1.15 atmospheres. So atmospheres again, that's got to be my pressure, 1.15 atm. All right, and at 14.5 degrees Celsius. That is my temperature. All right, I'm going to just keep on reading the question. If the volume of the gas is 8,560 milliliters, so we have 8,560 milliliters, how many moles do we have? So it looks like we're in pretty good shape. Oh, R, what? R is always the same number. So that one, if you're like, what about R? Oh, R, remember, R is always going to be 0.08206. Now, as far as this goes, I'm feeling pretty good. We got every number except for moles, so we should be able to plug in those numbers and solve for N. Now, before we do that, there's one more thing. Don't just put in those numbers. You got to make sure they're in the right unit. So I want you to take a look at that list, and I want you to tell me or think about which of those are in the wrong unit. Are any of those numbers, are we going to need to convert any of those numbers before we plug them in? Which of those numbers are in the wrong unit? Okay, it should be that, oh, we got a problem with temperature. Temperature is supposed to be in Kelvin, and volume is supposed to be in liters. So before we just plug in those numbers, we need to convert them. All right, so volume is supposed to be in liters. So we have milliliters right now. We haven't done this in a while. Let me just remind you. The way you can convert between milliliters and liters, let me just put it at the bottom here, actually, because I don't have a lot of room. 1,000 milliliters is 1 liter. That's kind of the easiest way to go between. So if we have milliliters, and I need to know this number in liters, the way I would do that, looking at that conversion factor I wrote down below, milliliters that needs to cancel, you got to put your milliliters on the bottom, and that makes the 1,000 go on the bottom, and the 1 liter would go on top. Okay, so converting to liters, basically you need to divide by 1,000. If you work it out, oh, the volume in the correct unit is 8.56 liters. 8.56 liters. All right, so that one is now good. Now, there's one other problem, which is that the temperature is in the wrong unit. It's in Celsius. It's supposed to be in Kelvin. So how do you convert it to Kelvin? Oh, you add 273. So if you add 273 on the Kelvin scale, let me check my notes here, works out to be 287.5 Kelvin. All right, so now I think we got everything. We got those four other numbers. We're solving for moles, so that's okay. We can solve for moles. And we got everything in the right unit. All right, now we can plug in. All right, so don't just start trying to plug in numbers. You got to make sure you have all the numbers you need and they're in the correct unit. I think we're okay now. All right, let me go ahead and put them in. So P, that's my pressure. Going to be 1.15 atmospheres. V, that's my volume. 8.56 liters. N is moles. That's what I'm looking for. R is that number. Always the same number. 0.08206 liter atmospheres over mole Kelvin. And while we're at it, we also have what else do we need? Oh, the temperature, 287.5 Kelvin. All right. So at this point, we should be in pretty good shape. We just got to solve for n. So now you got to do a little rearranging. You basically need to move the point 08206 and the point, the 287.5. You got to move, oh, that color's not showing up. You got to move these two numbers to the other side because you're trying to get n by itself. So the way you do that, if you're trying to get them to those two numbers to the left side, so n is all alone, you divide by them. So let's go ahead and do that. Now, if you divide, well, that looks good because it's going to cancel, right? And again, if we do that on the left, that means you also have to do it on the right. Oh, sorry, if you do it on the right, you have to do it on the left. And then you have to also divide by the temperature. Now, if I do that on the right, I also have to do it on the left. Getting a little messy there. I think you could see that though, huh? All right, so let's go ahead now. If you look on the right-hand side, oh, those two numbers cancel out, and we're left with this. N, my moles, equals, let's see, it would be equal 1.15 atmospheres times V, the volume, divided by R. Oh, shoot. I'm trying to write all these units out. And then also divided by T, of the temperature. Okay, so that's what it should look like. Now, if you multiply all those numbers together and divide them, you type in your calculator correctly, you should get that you are going to end up with 0.415 moles. That's what you should come up with. All right, let's just confirm a couple of things. First off, our units should work out. Let's just make sure they are doing it. And it's a little hard to see, honestly, but I think they do. All right, so do they? Yeah, we have an atmospheres on top and atmospheres on bottom. We have a Kelvin on bottom. We have a Kelvin down here. It's like in the denominator of a denominator. So that's also going to cancel. And we have a liters on top and a liters on bottom. That's going to work out. So the only unit that's left is moles. So that's the way it should work because I'm asking you to solve for moles. And then what else do I want to mention? Oh, one more thing. In sapling, when you do this, I might need to double check, but at least on some of the problems, they might tell you to use R. And I should have mentioned this earlier. You might sometimes see R written this way, 0.0821. So I'm giving you like 4 sig figs in R. That would be rounding it to 3. So this is also a value of R that you're going to run across. Don't get confused by that if you see it in your homework assignment. All right, 0.0821. It's just rounded a little bit more than what I've done. All right, so with that, we have found that in this sample of gas, that's how many moles of oxygen there are. So, you know what? I want to kind of continue this problem, actually. So let's kind of pretend that there's a part B to this question, all right? So let's pretend now, like we figured out how many moles of oxygen there were, and then, maybe there was a part B and it said, okay, great. Can you tell me, let's see if I can fit it in here at the bottom, how many grams of oxygen do you have? All right, so let's say there was a part B to this and I asked you that. How many grams of oxygen do you have? All right, well, wait a minute. This is why we end up using this equation so much. Because this equation has to do with moles. PV equals nRT has to do with moles. So if you know moles, you can relate it back to all that old material that we talked about. For example, grams. So moles and grams are related. They're like cousins or something, right? They hang out together all the time. All right, so if you just figured out that you have 0.417 moles, oh, by the way, of oxygen, you could figure out the weight of that oxygen. Now to do that, you gotta go back in your memory. Moles to grams. So if that was the part B of this question, hey man, I have 0.417 moles of oxygen. How much does this oxygen weigh? You can go from moles to grams, can't you? And how do you do that? Oh, you got to use your periodic table, right? So another thing I want to tell you, we'll do that in a minute, is if you're going like, when do I use this equation? If you see a problem that has to do with moles, PV equals nRT. Or if you see a problem that has to do with grams, you're going to end up using PV equals nRT. Grams isn't in this equation. P and V and N and R and T, none of those are grams, but you can always go from grams to moles. And the way we do that, right, that's our periodic table. So grams, if you see grams, that's also maybe a hint that, oh yeah, PV equals nRT is something that's going to help you out. All right, so with that, let's do this part B. How many grams of oxygen do you have? All right, so to do that, I need to bust out a periodic table. So only flip over. And a second ago, we just figured out that this sample of oxygen has 0.417 moles of oxygen. So part B is, oh, I should write it down here, I guess. How many grams of oxygen, right? I'll just rewrite it. How many grams of oxygen are there? All right, so moles to grams. Oh, we've done this. It's been a little while. Moles to grams. How do you do that again? You look at your periodic table, and for oxygen, it says 16 underneath there. Now, actually, it's O2, isn't it? So we got to multiply oxygen times 16, because there's actually O2. If you multiply it together, you get 32, don't you? Oh, what did that mean again? 32 grams equals a mole. So our periodic table is our conversion factor. The weight off the periodic table is how many grams it takes to make a mole. So with that, let's see, what are we going to do? So what we would do then is we would go from grams to moles. Let's see. Well, you tell me. We're up here now. Here's our work. Here's our conversion factor. Are you going to end up multiplying by 32 to get to grams, or are you going to divide by 32? You should multiply. All right, so you would do 1 mole on the bottom, 32 grams on top. It should look like that. Oh yeah, that's going to work. So this oxygen, this, I don't know, balloon full of oxygen, whatever it is, if you work it out, it weighs 13 grams. All right, so grams and moles, they're related. So if you know one, you can always know the other one. That's kind of what this part B was about. All right, I want to show you one more question in this video that's going to use PV equals nRT. All right, let's do one more example in this part. Okay, another example. All right, let's look at the question. It's over there on the left. I have 14.8 grams of nitrogen are at STP. What's the volume of the nitrogen? What? Oh man, this seems a little different, doesn't it? 14.8 grams of nitrogen are at STP. What's the volume of the nitrogen? All right, so first off, wait a minute. STP, never heard of that before. Well, let me tell you what that means. STP stands for standard temperature. Standard temperature and pressure. Standard temperature and pressure. Now, so it's kind of like saying normal temperature and pressure. So what do we consider normal? Like you're gonna need a number, don't you? You can't just say put in normal. So normal temperature is 273 Kelvin, and standard normal pressure is gonna be 1 atmosphere. All right, so that's what that means. All right, so really that's a secret way of telling you the temperature and the pressure. 14.8 grams of nitrogen are at STP. What is the volume of nitrogen? All right, so we've got a bunch of equations. So now we got to start knowing which one to use. So as I said a minute ago, the tip-off that we got to use PV equals nRT is the fact that it says grams. Grams goes with moles, and moles is in PV equals nRT. It's the N, right? So what we're going to need to do, we're probably going to need to use this equation. I kind of got that idea because it has to do with grams, or they're telling me grams. And what I'm going to solve for in this equation, what is the volume? I'm solving for V. So to be able to do this, we got to know all the other numbers, right? So let's make a little list and let's see if we got them. I hope we do. If not, we'll have to do a little extra work or maybe do a little converting. I don't know. All right, so I'm going to make my list over here. P, V, N, R, T. If you are looking for V, you need to know everything else. All right, let's look. Do we have it? 14.8 grams of nitrogen are at STP. Oh, STP? That means the pressure is 1 atmosphere. And it also means the temperature is 273. All right. We always know R, don't we? R is always that same old number, 0.08206. All right. So the only one I'm missing so far, I got pressure, I got R, I got temperature. V is going to be my unknown. So before we can plug in, we have to have moles. Now, we don't quite have moles yet, do we? Grams are not moles. Grams and moles, they're not the same thing, but they are related. So when they're telling me grams, 14.8 grams of nitrogen, I can know the moles. I'm not going to put 14.8 in the equation. That's not going to work. But if you know grams, you can get to moles. How do you do that? Oh, you use your periodic table again, right? Nitrogen is 14.01, and 2 nitrogens is going to make 28.02, and that's how many grams equals a mole. 28.02 grams makes a mole. All right, so with that, let's go ahead and see what we can do. Okay, so N is moles. So before I plug in, I've got to take my grams and go to moles. All right. Oh, this should be moles here. All right, we got our conversion factor. Oh, I'm going to ask you the question I always like to ask you. Multiply or divide by 28 to get to moles. You should divide. So you would put, oh, well, that's okay. Yeah, let's switch back to the color. All right, 28.02 grams would be on the bottom. The 1 mole goes on top. Oh yeah, if we use the weight off the periodic table, if we divide by it, that should work. Let me check my notes. When I did this, oh shoot, I gotta flip the page here. We have 0.528 moles of nitrogen. 0.5, is that what I got? Yeah, 0.528. All right, so with that, now we're in business. We've got 4 out of the 5 things. We're just solving for the last one. We're solving for V. So let's plug in our pressure. Now, I don't have a lot of room, so I think I might leave off the units on some of these. I'll just put in, I'm sorry, I can't quite fit in. So the pressure is 1. The volume, I don't know. N is my moles. R is that number. T is my temperature. All right. So now we're going to solve for V. All right, so solving for V, this isn't actually going to be too bad. Look at that equation. When you want to solve for V, we just have to move 1 to the other side, don't we? So we just need to divide by 1. All right, so if we take both sides and divide by 1, which is kind of boring, honestly. When you divide by 1, you get the same thing, don't you? But it's going to cancel out over here on the left side. That's what we want. So then you get that the volume equals this. I would love to write out the units, showing you all the units, but on my tiny screen here, I don't think I would have room. All right. All right. Oh, I kind of put in Kelvin. I guess I couldn't stop myself. All right. And then we divide by 1. If you work it out, let me just tell you, you should get an answer of 11.8. And the units, what are the units whenever you use PV equals nRT? The volume has to be in what? Liters. So it's going to turn out to be in liters. If you wrote out all the units, you could see how everything cancels except for liters. All right, so this is one way we can use PV equals nRT. Basically, what have I shown you so far? With this equation, if you got 4 out of these 5 things, you can solve for whichever one you're missing. In this case, I was solving for V. The other thing that I've talked about is when you use this equation, you can also bring in grams because grams and moles are related. So you can go between them if you need to. All right, so with that, that's it for part A. We're going to move on to part B, and in part B, we're going to keep using this equation, but for other reasons. All right, that'll be coming up in a minute.